It's a moment of triumph for NASA after months of troubleshooting a bizarre communication glitch with the legendary Voyager 1 spacecraft. For the first time since November, this intrepid explorer is back in meaningful contact with Earth from the edge of interstellar space, 15 billion miles away. Let's rewind to November 2023, when Voyager 1, which has been journeying through the cosmos for nearly half a century, suddenly stopped transmitting coherent data. Instead of its usual mix of scientific readings and health updates, it began sending a garbled, repetitive stream of ones and zeros that got engineers a bit worried. You see, Voyager 1 communicates via binary code, employing only the numbers 0 and 1 to represent all kinds of information. Its three main computers, running at 8,000 instructions per second, super slow for modern standards, collect data from instruments studying the universe and the spacecraft's health. This data is then processed by the Flight Data System, or FDS, into a single package for transmission. The FDS first gathers two types of data: scientific observations from Voyager's instruments and engineering telemetry, indicating if all spacecraft systems are operating correctly. It combines this binary data into one package that gets handed off to the Telemetry Modulation Unit, TMU. This modulates the binary data onto a carrier signal for transmission to Earth via NASA's Deep Space Network of radio antennas. But for reasons unknown, the FDS was corrupting this package, resulting in the weird signals received on Earth, despite Voyager still getting commands. Rebooting the FDS did nothing to solve the issue, prompting a deeper investigation by NASA's personnel. Using a special poke command in March 2024, which can directly modify a computer's memory value, engineers managed to extract a full readout of Voyager's FDS memory. By comparing it to past data, they identified the culprit. About 3% of the memory was corrupted, including code for handling spacecraft health telemetry. The cause? A faulty computer chip responsible for storing part of the FDS memory and software code. And with Voyager 1 billions of miles away, physical repairs were impossible. The only solution was a brave plan to remap and divide the affected code into different memory locations within the FDS. It was no easy feat, given Voyager's 1970s computer has just 69 kilobytes of memory to work with, tiny by modern standards. The team spent months devising a strategy to split the corrupted code into chunks while ensuring it still functioned as one unit, a process made very annoying by the 45-hour round-trip delay for each signal to reach Voyager and get a response. The first step was relocating just the spacecraft engineering data handling code on April 18th. After an agonizing wait, the breakthrough came on April 20th. NASA received coherent spacecraft health data for the first time in 5 months. Their fix that worked, restoring a critical line of communication. While more remapping lies ahead to fully restore science operations, this first step means we can continue gaining unprecedented insights into interstellar space cosmic rays, magnetic fields, and the boundaries of our celestial neighborhood. Even though Voyager's power supply is projected to be exhausted by 2025, cutting off communications forever, every bit of data is precious for unraveling the mysteries of our universe. Let's remember that both Voyager 1 and its twin spacecraft, Voyager 2, carry a message from Earth for any advanced civilizations that might find them. The Voyager Golden Phonograph records were placed on both spacecraft. These records aim to provide a glimpse of Earth and its inhabitants to any extraterrestrial intelligence that may encounter the probes in the distant future. The records include sounds from Earth such as thunder, bird songs, and ocean waves. They also contain greetings in 55 languages and musical pieces from various cultures around the world, like Bach, Beethoven, and even Chuck Berry's Johnny B. Good. Additionally, the records feature 116 images showcasing different aspects of life on Earth, including landscapes, animals, human anatomy, and scientific diagrams. It's worth noting that the content was curated by a committee led by the renowned astronomer Carl Sagan. The records, made of gold-plated copper, are designed to endure the harsh environment of space for billions of years. Each record is housed in an aluminum cover with playback instructions engraved on it, detailing how to build a stylus and cartridge to play the records. There's also a diagram showing the sun's location relative to 14 pulsars, which can be used to determine the spacecraft's origin, time, and place. While the main purpose of the Golden Record is to send a message of goodwill from humanity to any extraterrestrial beings that might intercept the Voyager probes, there is a slight concern that if hostile aliens find them, we have essentially provided them with directions to Earth. Let's hope that doesn't happen anytime soon.